So we could find the limit as x approaches the 1 of f of x for now. Now the limit means it's getting closer and closer to. So as I go from the right and from the left, what y value am I getting closer to? 2. So we have our 2. So when I plug it in, we have sine of 2. Now is this calculator active or inactive? Active. So get your calculator out. And let's plug in sine of 2, because sine of 2, that's not a special triangle, so we can't even do anything about it. What mode should we be in, just in case you're thinking, well, I remember back in geometry, we were always in degree mode. We should always be in radian mode for calculus, okay? So when I plug in sine of 2, that's going to give me to 3 decimal places, will be 0.9, how many? 909, thank you.
What would you get if you were in degree mode?
Oh, in degree mode? Let's try it. Because for sure it's got to be different. So.
Yeah, I'm gonna frame that.
Degree would be more for geometry.
I just want to
Or the nice thing is, your mode by default, when you reset your calculator, it'll set you on radian anyways. So if you forget, it might be okay. So we have 0.909. What's up?
Do we have to bring our own calculators for the AP test?
I believe so.
I don't have one.
You don't have one. We'll figure something out.
They gave it to us last year.
They did?
Really good.
When we get near it, I'll ask them. All right, let's go to number 23, everybody. 23. Ooh, story time right here. Sam, let's read.
Constant function f is divided on the closed interval -4 by s less than or equal to x is less than or equal to 6. The graph f constant of the line segment is a curve that is tangent to the x-axis at x equals 3. As shown above, on the interval 0 is less than x less than 6, the function f is twice f double prime greater than 0.
Part A.
F
Is it differentiable?
F at 0.
Uh-huh.
X. Reading is difficult.
Me too. It's okay. I'll finish it. So it says it use a definition of the derivative with one-sided limit to justify the answer. So just by looking at this, when it is equal to 0, what is that thing called right here? We have a cusp. So we know automatically it is not differentiable. So is it differentiable? The answer is no. Now you have to defend it as to why it is not. So let's write out limit as x approaches 0 from the left. And then we want to also find the limit as x approaches 0 from the right. And in our case, our f prime of x. So on my left, can we do rise over run to find the slope?
Yeah.
Okay, because f prime is the slope of the function. So how many are we going up and how many are we going across? Up 2 over 3. So now we know the second piece will not be equivalent to 2/3. So we know the next one, f prime of x. This one right here, we know the graph is going down, correct? It doesn't matter what number it's going to be. We know it is going to be a negative slope. So let's write negative. Because we know that negative, whatever that number is, will never be equivalent to 2/3. So that automatically lets us know it's going to be no, it's not differentiable. So here's our summary. Justifying your answer is going to be some points on the AP test. So limit. Restating the question is always good. As x approaches 0 of f prime of x does not exist. And f of x is not differentiable at x equals 0.